So I will try to explain delays in digital circuits, and I will have the intuition, like I will give the intuition explanation. Okay, so let us suppose we are having two nodes. Let us suppose this is one node and this is another node, and let us suppose this node, let's say it as A and this is B, and let us suppose we applied 1 volt here and this is at 0 volt, and let's suppose there is some wire or some material between the two nodes, and if we try to have these both nodes to the same voltage level, the current has to flow between the two. Okay, the time it takes depends on the resistance of this material. If it is let us suppose copper, the resistance will be less. If it is iron, the resistance will be less. If it is some let us suppose it is a wood, so it will be high. The higher resistance, the current will not flow. So the time it takes depends on the resistance of the path connecting between these two nodes, that is A and B. Higher resistance slows down the current, so it takes more time for the voltage between this A and B to equalize. And if there is a zero resistance between the two A and B, so it is like a short circuit and it will have a zero delay, while as in higher resistance path we will have some time period after which A and B will equalize. Okay, so that is a delay, means how much time it takes for having both A and B to equalize the voltage level, and it depends on the resistance between the two nodes. While in real digital circuits, especially in CMOS technology, we don't just deal with resistance, we have capacitances as well, and this capacitances comes from the physical structure of the MOSFET, overlapping metal layers and the junction between the materials. And if we let us suppose we have this PMOS, and there are capacitances like this is one capacitance here between gate and body, and another capacitance is here, another capacitance is here, another capacitance is here, and another is here. So there are almost 1 2 3 4 5 capacitances occur in one device. Okay, there is one PMOS and there are 5 capacitances. So if let us suppose we have this PMOS, and let us suppose we have Vn is equal to 0, means this is on, this switch is on, and let us suppose we apply here VDD is equal to 1.2, and let us suppose this is ground, and let us suppose we want this VDD to appear here or this ground appear here, so means we want to equalize both of them. So there will be two quantities that will occur here. One is resistance, another is capacitance, and this resistance will occur because there is some material and it has the resistance, it has the opposition to the flow of current or the flow of charge, and the capacitance will come because we have these capacitances there, and if we have to appear here 1 or 1.2, it means we have to charge these capacitances, and if we have to appear here 0, it means we have to discharge those capacitances. So accordingly, the time taken to charge and discharge those capacitances, and also this resistance offered by this device, it have the effect on the time it takes for to equalize the two nodes for the same voltage level, and that is a delay in digital circuits. And why we are not taking this L inductance into the consideration, because these circuits are working on low frequency, and at lower frequency the inductance has a negligible effect, so we don't take into consideration that.